So now that we know that what our rules are for writing our electron configuration, we can now use this little diagram here to help us write them for all of our elements, no matter how many electrons they have. Okay, so just a reminder of our general rules. Electrons will reside in the available orbitals of the lowest possible energy. So here in our diagram that you have on in your packet and in your test taking resources, this is lowest energy, and this is highest energy. Okay, each orbital can accommodate a maximum of 2 electrons. So each box that we have has 2 electrons in it. Electrons will not pair in orbitals if an empty orbital is available. Okay, and that's only in things like 2p and 3d, where we have multiples at the same energy level. And orbitals will fill in the order indicated in this figure. So we're going to use this figure a lot to start writing our electron configurations. And what we have to do is start following the arrows. So we start with 1s. Then when we're done with 1s, we go to 2s, which is what we saw in all of our configurations. Once we're done with 2s, we go to 2p, and then we go to 3s. Once we're done with 3s, we go to 3p, and so on and so on. So you follow the arrows as you go, and they kind of come back up once you finished one arrow. Okay, so that's what they mean by follow the order indicated in the figure. So let's do one example together where we use this diagram to write our electron configuration. So we have calcium, which has 20 electrons. So 20 electrons that we need to organize into specific orbitals. So we start here, we have 1s. Okay, and we know that the s orbital can hold 2 electrons. Actually, I'm going to do this a different way. We're going to draw our orbital diagram first. So 1s, we have 2 electrons. So then we go to 2s, which is next, which is another single box. Okay, so that's 2s, that's 4 electrons total. We have 16 electrons left. Once I'm done with the 2s, we go up to our next row and we do 2p. So 2p is our 6. We have 3 boxes that show our 2p. So we're going to do 1, 2, 3, 4, 5, 6. So note how I've added my electrons in following Hund's rule, where I put them without being paired up until they have to. That'll be very important for when you have we don't have completely full shells, when we don't have completely full orbitals. Okay, so you always want to follow those rules even when you're filling in. So next up we have 3s, and let's just take count of how many electrons we've used. We've used 2, 4, and then this is what, 6. So we've used 10 electrons so far. Okay, so my 3s is going to be 2 electrons. Okay, so that's now 12 electrons. I now move up to my next row. I go through my 2p, or my 3p, sorry. My 3p, which again has 3 boxes in it. And we do 1, 2, 3, 4, 5, 6. Let's take stock. That's what, 6, 12, 14, 16, 18 electrons. So that's my 3p. So I need 2 more electrons, and we come up to our 4s next, which holds 2 electrons. So that's a total of 20 electrons. So that's the orbital diagram for calcium. Now we can take that orbital diagram and turn it into an electron configuration. So we have 1s, there's 2 electrons in that one. 2s, there's 2 electrons in the 2s. 2p, there's 6 electrons in the 2p orientation. So remember, we have 3 orientations of p. Each can have 2 electrons. So in total, the p orbitals overall can house 6 electrons. So we put our superscript as a 6. We then have our 3s, and that has 2 electrons. We have our 3p, which again is filled with 6 electrons. And we have our 4s, which has 2 electrons. So we've written our orbital diagram, as well as our electron configuration. Now I drew my orbital diagram linearly, mainly because drawing them with specific energies or going up in energy can be, there may not be enough room, but on your Alex homework you may be asked to draw them at their specific energy levels, which Alex will give you the lines to do that, so just keep that in mind. But a linear orbital diagram like this one is perfectly fine because you're showing the energy from lowest on the left to highest on the right. Okay. Let's do a few more examples. Now, with electron configurations, it really just comes down to practicing and following this diagram, because you'll then start to learn kind of the overall pattern of the electron configuration, because electrons, what we're counting here, are literally just counting numbers, 1, 2, 3, 4, 5, so on. So it really is kind of just truncated by how many electrons you have. So you'll notice a lot of similarities. We're going to start with 1s, then we're going to go to 2s, then 2p, because they're following this diagram. So you're going to notice that a lot of these have they start off very similarly. So the first thing we want to do is, with lithium, we want to figure out how many electrons it has. Okay, so lithium has 3 electrons. We get that from the periodic table. So I have 3 electrons that I need to put into my electron configuration and my orbital diagram. I personally find it easier, as you're learning, to draw out the orbital diagram and then write the electron configuration, because you're physically seeing where the electrons are going. So let's start with the orbital diagram. We're going to start with our 1s. We're going to go through here. 1s, that has 2 electrons. Okay. And then we go into our 2s. And that can hold 2 more electrons, but I only have 1 electron to utilize. And that's 3 electrons total. So lithium only has 3 electrons. So those electrons are organized with 1s, 2, 2s, 1. There's 2 electrons in the 1s orbital, in the lowest energy orbital, and there's 1 electron in the 2s orbital, the higher energy level. Okay, we've seen that one before, so let's move on to fluorine. Fluorine, if we look on our periodic table, has 9 electrons. Okay, so let's start drawing. Get rid of our lines here. Let's start drawing our orbital diagram. We're going to start with the 1s, because that's where our diagram tells us to go. So that's 2 electrons. We then have our 2s, that's another 2 electrons, so I've used 4 electrons so far. Okay, so that was my next one, my 2s. So after 2s, I go up and I use 2p, which has 3 boxes. Okay, so I have 4 electrons. I've used 4 electrons. I have 5 electrons left. So I do 1, 2, 3, 4, 5. So here's a case where we don't have enough electrons to fill our p orbital or our s orbital or whatever. We have an unfilled orbital, which is totally fine. There's not enough electrons to go around. So we just leave it as is. And this is why following Hund's rule is very important, because we want to show that we first maximized our spin before we paired them up. Okay. So our electron configuration then becomes 1s, 2, 2s, 2, 2p, 1, 2, 3, 4, 5. And again, if we add up our superscripts, 5 plus 2 plus 2 equals 9. 9 electrons in fluorine. Okay, let's try one that's a little bit more difficult. Rubidium. Let's find rubidium on our periodic table. And let's see, how many electrons does rubidium have? Let's see, it has 37 electrons. Whoa, this one's gonna need a lot of space for this one. 37 electrons that we have to put into these boxes. So we're going to use our chart because our chart is going to tell us the order that we have to fill them in. So we're going to start with our orbital diagram. 1s, we know that there's 2 electrons there. 2s, there's 2 electrons there. Now, so we've done 1s, 2s, now we do our 2p. Oops, I made that far too large. 2p, 1, 2, 3, 4, 5, 6. So I've used 10 electrons as of right now, so I have 27 left to go. After 2p, I go into my 3s. That holds another 2 electrons. I go into my 3p next. One, 2, 3, 4, 5, 6. And after 3p, we go to 4s. And that has 2 electrons. Here's where I oftentimes see students run into issues. After 4s, our next spot is the 3d. Now, students get confused by this because 3 is lower in number than it is 4. But if you remember back to our slide where we talked about different energy levels, when we have multi-electron atoms, we said that the energy levels start to change and how the 4s was more energetically favorable than the 3d. This is where it's coming out because we have to fill our electrons from lowest to highest energy. 4s is lower in energy than the 5 orientations of 3d, which is why it comes first. And that's what our diagram here tells us as well. So as long as you're following this diagram, okay, you will not put anything in the wrong spot. So just follow the diagram as is. So with 3D, there are 5 orientations, so I need to draw 5 boxes. Okay, so 5 boxes. There's my 3D. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's just see, how many electrons do we use? Well, that's 10. So that's 2 plus 2 plus 6 is 10. Then we have 2 plus 6, that's 18. That's 2, that's 20. And 3D has 10, so that's 30. So I now have 7 electrons left to do my orbital diagram. So after 3D, we have 4p, so that's 3 boxes. 4p, 1, 2, 3, 4, 5, 6. Okay, so that's another 6 electrons. So I only have 1 electron left, and that 1 electron is going to go in my 5s orbital. And it's just going to be by itself there, because there's no more electrons to put in there. So it's okay to have unpaired electrons if you don't have enough electrons left. Those unpaired electrons, as we can see, should be in our very last orbital of our orbital diagram. You don't want to have unpaired electrons in one of these random orbitals down here, because then you would be not following all of our rules where we say we have to go from lowest to highest energy, pair up only when we have to, and stuff like that. So we got to follow those rules, and what those rules will tell us is that all of these unpaired electrons should be in the very end. Okay, so now that we have our orbital diagram, we can use that to draw our electron configuration. So in my 1s orbital, I have 2 electrons. In my 2s orbital, I have 2 electrons. In my 2p orbital, I have 6 electrons. In my 3s orbital, I have 2 electrons. In my 3p orbital, I have 6 electrons. In my 4s, I have 2 electrons. In my 3d, I have 10 electrons. In my 4p, I have 6 electrons, and in my 5s, I only have 1 electron. So my electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. Okay, so when we went from 3D, we jumped back over into the 4Ps because 4P is now higher in energy than 3D, and then we go into our 5s. So we have to remember to follow this diagram whenever we are doing our electron configurations so we don't get caught up in numbering incorrectly when we go between 4 and 3, as well as when we go from 4 and 5, when we get into the next d orbitals and stuff like that. So it happens all the time. It happens throughout here. We go 4s or 5s, then we come up here, and now we're in the 4d. Then we go 5p, 6s, 4f, 5d. So they're offset, and we'll talk about why here in a second. Okay, so what I want you to do is I want you to pause the video, and I want you to try some of these on your own. So we're going to look up on the periodic table how many electrons each of these has. We're then going to utilize our diagram to write out our orbital diagrams to then write our electron configuration. And my last question here is to indicate how many unpaired electrons the atom has. How many unpaired electrons does this atom have? So take a second, pause the video, and try these on your own. We'll come back together here in a second to work on them together. Okay, phosphorus I have as having 15 electrons because it is element number 15. Don't confuse phosphorus with potassium. Okay, potassium is K and it has 19 electrons. This is phosphorus P with 15 electrons. Now, what I'm going to do is I'm going to just write the electron configuration, not the orbital diagram, for each of these, just so you can see how to use this diagram without having to draw the orbital diagram. If that makes you comfortable, if that's the way that you're seeing it as you learn it, then please feel free to do that. But you should also get comfortable with not drawing the orbital diagram and being able to use this diagram here to just write out the electron configuration. You should be comfortable with either way. So for this one, I'm just going to draw the electron configuration or write it out without drawing the orbital diagram at the same time. Okay, so we start off with 1s, and I know that can hold 2 electrons. We then jump up to our 2s, which again can hold 2 electrons. After 2s, we go to 2p, which we know can hold 6 electrons maximum. And after 2p, we go to 3s, which can hold 2 electrons. I'm just going to take a second to pause and make sure I haven't used too many electrons. So I have 2, 4, 10 electrons, 12 electrons total. I have 3 electrons left, so let's see where those 3 electrons are going to be. Well, they're going to next go into the 3p, and I only have 3 electrons to give away. So that's not going to be a full 3p6 because there's not enough electrons. If you put 3p6, if you added those up, you would have 18 electrons, which is too many. Okay, so remember, always double check your own work and show that you have the same number of electrons in your electron configuration as you do the element. So this equals 15 electrons. Okay, so my next question was how many unpaired electrons are in the atom? Well, if we look at an orbital diagram for 3p, if I have 1, 2, 3 electrons, I'm going to put them into their individual boxes before I start pairing them up. Since there's only 3 electrons, I put 1 electron in each box, meaning I have 3 unpaired electrons. So each of these electrons are in their individual orbitals, not paired up yet, so they're unpaired. Okay, let's try the next one. Nickel. Nickel I have as having 28 electrons. It is element number 28. So again, let me just erase my lines here so we can still see. We're going to follow our diagram. We start off with 1s. We know that can hold 2. After 1s, we jump into 2s, which again holds 2. Once we go there, we go to 2p. That holds 6 electrons. After 2p, we hit 3s. That holds 2 electrons. We jump into 3p, which holds 6 electrons. And then we jump into 4s, which holds 2. So let's count our electrons. We have 2, 4, 10, 12, 18, 20. So I have 8 electrons to go. My next orbital after the 4s is our 3d. So again, we're just following our diagram. We know that the 3d is higher in energy than the 4s, so it's going to come after the 4s. So 3d, well, we know d orbitals can hold a maximum of 10 electrons. I only have 8 electrons to give away, so those 8 electrons are going to go in my d orbital. So to look at our unpaired electrons, well, d orbital has 5 orientations. So we have 1, 2, 3, 4, 5, 6, 7, 8. We filled those based off of Hund's rule, and because of that, I have 2 unpaired electrons. Okay, carbon next. Carbon has 6 electrons. Okay, so we're going to follow our lines again. So we start with 1s. 1s has 2. Then we jump to our 2s. That has 2. Then we jump to our 2p. We know that has 6. But if I take stock, I have too many electrons. I have 10 electrons there, and I only had 6 electrons to give away. So we're going to erase that. Let's see, I have 2, 4, so I have 2 electrons left. I add those up, that's 6 electrons. So if I look at my 2p diagram, I have 1, 2, meaning I have 2 unpaired electrons. So sometimes we just don't have filled shells, and that's because there's not enough electrons to fill them, which is totally fine. That's how we differentiate all of our different elements. Okay, argon. Let's do argon next. Argon has 18 electrons. Okay, so let's follow our plot. We have 1s, 2. We jump over to 2s, 2. We then go to 2p6, that's 10 electrons. I have 8 left. 3s, 2. And now we're into 3p6. So let's count. 2, 4, 10, 12, 18. That's 18 electrons. If we look at our 3p orbital, 1, 2, 3, 4, 5, 6, we have no unpaired electrons. Okay, so hopefully you're starting to see that with each one of these, if something has more electrons, so let's look at phosphorus and nickel, we're starting off all in the same. So 1s2, 2s2, 2p6, 3s2, blah, blah, blah. If it has more than those electrons, well, you just keep on going. Okay, so I only have 6 electrons in carbon, so it's 1s2, which starts off everything else is 1s2, then we go to 2s2, then we just stop in the 2p. So it's getting very repetitive, and all you have to do is just stop at the point that you've used up all of your electrons. And if you ever forget your order, you just follow the diagram.